So we're in section 8.3, looking at what's called the law of cosines. The law of cosines. So let's say I have a triangle, ABC, with sides little a, little b, little c, as in the triangle, right here. And we're going to come up with a nice formula, which we're going to call the law of cosine. So let's say I take a perpendicular altitude or height here. Call this little point here D. So here A is basically BC. Little a, right? Little a is the distance from B to C. I'm going to call BD I'm going to call A1, and DC or CD I'm going to call A2. So basically A1 plus A2 gives you big A, A1 plus A2 gives you little a, I should say. Now let's focus on the cosine of C here. I'm focusing on C, angle C. So the cosine of C, what will that be? That will be adjacent here over the hypotenuse of this right triangle. So A2 over B, right? A2 over B. I can't get this to right up there, okay. I'll bring the B up here, cross multiply, I get B, cosine of C equals A2. Okay, now what if I wanted A1? If I wanted A1, well, to get A1, remember here that A1 plus A2, what's that? A1 plus A2 gives you all of A. So here I have that A1 plus, remember A2 is B cosine of C, that's equal to A. So if I wanted A1 by itself, it would be A minus B cosine of C. There's a formula for A1. All right. So I got that formula for A1. Now, let's take the sine of big C. The sine of big C. So the sine of big C, so here's big C right here, right? That would be the opposite over their hypotenuse. So that would be AD, the opposite over the hypotenuse, over a little b. So I'll bring the little b up here in front of the sine of C, cross multiply, and I'm going to get b sine of C is AD. Now, let's focus on the relationship between A1, AD, and little c. That's a 90-degree triangle right there, right? You have a little 90-degree corner. It's a right triangle, so you can do the Pythagorean theorem, right? We can say A1 squared plus AD squared equals C squared. Now let's keep in mind another name for A1 is A minus B cosine of C. We're squaring that. Plus, remember AD is B sine of C. Squaring that, and then we got that's equal to C squared. So if I simplify this nicely, remember we take A minus B cosine of C, the green, when we square that, we got to actually FOIL that out, right? We're multiplying it by itself. We got A minus B cosine of C, A minus B cosine of C. When I square B sine of C, that's just B squared sine of C squared, or sine squared C, equals C squared. Now I'm going to FOIL the green. Do the first, oh, that wasn't good. I'm going to do the first. It's not working. First, a times a is a squared. Outer, a times negative b cosine c is minus ab cosine of c. Inner, negative b cosine c times a is minus ab cosine of c. And last, negative b cosine c times negative b cosine squared is b squared cosine squared c. And we got plus the yellow, plus b squared sine of c squared, or sine squared c, equals c squared. So I'm going to put some stuff together. I'm going to keep a squared where it is. The minus ab cosine c, and the minus ab cosine c is going to become minus 2ab cosine of c. And then we're going to have here on the end plus b squared cosine squared of c plus b squared sine squared of c equals c squared. So the two reds, we can factor out a b squared, right? They both have a b squared in common. So I'm going to have here a squared minus 2ab cosine of c. And when we factor out that b squared, we're going to be left with, let's see, cosine squared c plus sine squared c. And all that's equal to c squared. Now let's keep in mind that the cosine squared plus the sine squared of c, that's just going to be 1, right? That's going to be 1. That's one of our trig identities. The cosine squared of an angle plus the sine squared of an angle is 1. So we actually end up with a squared minus 2ab cosine of c plus, so we're going to have b squared times 1 is b squared equals c squared. And this is in essence our law of cosines formula. Now, there are actually 3 versions of the law of cosines. We'll call them formulae, plural. Version 1 is the one we just developed, right? We got c squared equals a squared plus b squared minus 2ab cosine of c. That's this one right here, just written slightly differently. Right, I notice I have the c squared on the left side, and I have a squared plus b squared minus 2ab cosine c. Now another version of this is if we have a squared by itself on the left, that would be b squared plus c squared minus 2bc cosine of a. And our third version would be if we have the b squared by itself, that's going to be a squared plus c squared minus 2ac cosine of b. So notice here, like when you have the b squared by itself, on the other side you have the cosine of big B. So when you have b squared by itself on one side, you have the cosine of big B on the opposite side, then you have little a squared, little c squared added, and then 2 times little a and little c there. Notice when you have little a squared on this side, you have cosine of big A on this side. It means on the opposite side of a squared, you have to have b squared and c squared added, and then minus 2bc. And then finally, like when I had c squared on one side, that means I have the cosine of big C on the opposite side. And on the opposite side, I got, let's see, little a squared, little b squared, and minus 2ab. You kind of see the pattern there. So what we're going to do, we're going to do some triangles, I guess. And we're going to solve the triangle, given the information. So let's say number 1, I got an angle A of 20 degrees, and I have a side of 11, that'd be its length in units, and I have a side C of 14 units. So drawing this out, A, B, C, little a, little b, little c. A's 20, little b's 11, little c's 14. But notice we got, hold up, wrong color. We have a side, angle, a side. When you have a side, angle, side in that order, if you have side, an angle, and a side like that, given, you can use law of cosines. So let's use law of cosines to first start with little a. That's going to be the side across from the angle. So finding little a, I'm going to use the one that has a squared, little a squared. So little a squared equals b squared plus c squared minus 2ab, 2bc times the cosine of big A. So we're looking for little a. We know b and c, and we know big A. So since this has a square, let's just take the root of the whole entire right-hand side. We have little a is going to be the square root of b squared plus c squared minus 2bc cosine of A. So I'm going to plug in. So for b I have 11, so I have 11 squared. For little c I have 14, so 14 squared. Minus 2 times 11, that's b, and little c is 14, and I have the cosine of 20, right? A is 20. So I'm going to plug that into a calculator. So I'll grab my handy dandy calculator. I'm going to take the square root of 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 20. Making sure that's in degrees mode, I get approximately, let's approximate this to 2 decimal places, 5.25. And let's see, did I get that? Yes, I got that. So A is about 5.25, the length. So once you have that side across from big A, you can find the angles big B or big C using the law of sines. So now we're going to go to the law of sines. This first one was the law of cosines. So now we're going to do law of sines, maybe to find big B. So if I wanted to find big B, I would take the sine of big B over little b, which is 11, equal to the sine of, let's say, 20, big A, over little a being 5.25. So to solve that, I'm going to bring the 11, cross multiply that up. I'm going to get sine of big B equals 11 times the sine of 20 over 5.25. And finally, to find big B, get rid of the sine on the left, you take it to the right, it becomes the sine inverse of 11 times the sine of 20 over 5.25. And when I did that, I got, let's see, sine inverse 11 times sine of 20 divided by 5.25. I got approximately, let's go to 1 decimal place on our angles, 45.8 degrees. Yep, 45.8. All right. So what do we have to find next? We got 45.8 for big B. Then we have to find big C. So we found big B. Yep. Now we find big C. So we know two of the angles, right? We know 20 degrees is A. We know B is 45.8. And we know big C. We don't know big C, but we know everything adds up to 180. So if we do that, let's see, we're going to get 65.8 plus C equals 180. So I'm going to take C to be 180 minus 65.8. And when I do that, I should get 180 minus 65.8 is 114.2 degrees. Okay, so that completes the triangle. So that was a side angles side situation. Now we want to do completing another triangle. Let's see, we have little a is 6, little b is 5, and little c is 8. So notice we have 3 sides of the triangle. 3 sides of the triangle. So little a is 6, little b is 5, little c is 8. So here we have a side, 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 right? All 3 sides. So if you have side, side, side given for a triangle, you can use the law of cosines. Oh, sorry, law of cosines. I said it right. Law of cosines. To find an angle. Let's find angle A. If I want to find angle A, I want to use the law of cosines formula that has a cosine of A in it. So that would be this one again. So that's going to involve A squared equals B squared plus C squared minus 2BC cosine of big A. Now remember, little a is 6, so I got 6 squared equals, let's see, b is 5, so I got 5 squared plus little c is 8, so 8 squared minus 2 times 5 times 8 cosine of A. I'm going to actually make cosine of A, let's make it green to distinguish it. We want to get that by itself. We want to solve for cosine A. So here I'm going to have 6 squared is 36. 5 squared is 25, 8 squared is 64. 2 times 5 times 8, that is negative 80 cosine of A. So if I'm solving this for cosine A, I'm going to add 25 and 64. I'm going to get 89. I'm going to get 36 equals 89 minus 80 cosine A. Let's make cosine A green. So now I want to subtract 89 from both sides. 36 minus 89 minus 53 equals negative 80 cosine of A. So now I'm going to divide both sides by negative 80. The negative 80s cancel on the right. I get 53 over 80 on the left, right? 53 over 80. That's going to be the cosine of A. And to solve for A, I'm going to take the cosine to the left. It becomes the cosine inverse of 53 over 80. And that'll be my A. Let's approximate this. So let's use our calculator. Cosine inverse of 53 divided by 80. That's going to be about 48.5 degrees. So once I have that, 48.5 degrees, I can use the law of sines to find one of the other angles. Let's find B. To find B, I'm going to take the sine of big B over little b, which is 5, equal the sine of big A, 48.5, over little a, 6. So I'm going to bring the 5 here on bottom up to the top. I'm going to get the sine of big B equals 5 sine of 48.5 degrees over 6. And then the sine right here, we're going to take it to the other side. It's going to become the sine inverse. We're going to get B equals the sine inverse. 5 sine of 48.5 degrees. All that divided by 6. So in my calculator, I'm going to take the sine inverse, 5 times the sine 48.5, close parentheses, and divide by 6. I get about 38.6 degrees. So once you have those two angles, A and B, so this one was 38.6. You can find the third angle, C, because remember, angles have to add up to 180 degrees in a triangle. So we have 48.5 plus 38.6 plus C is going to be 180. So we're finding C. 48.5 plus 38.6 plus C equals 180. So I'm going to add 48.5 plus 38.6, get 87.1 degrees plus C is 180. So to get C, we're taking 180 minus 87.1. When we do that, we get 180 minus 87.1. I got 92.9 degrees. And that completes my triangle. I got all the angles. I had all the sides, and now I have all the angles. So you don't always want to use just law of cosines. Usually law of cosines is a starting place, and from there you can maybe use law